hundreds. Hidden inside every smartphone, computer, electric vehicle, and AI system lies one of the most. Every microchip begins as quartz, a naturally occurring mineral rich in silicon, the foundation of modern electronics. Through multiple refining stages, impurities are removed until the silicon reaches extraordinary levels of purity required for semiconductor manufacturing. A single crystal is carefully grown atom by atom, forming the foundation for hundreds of future microchips. The crystal is sliced into ultra-thin wafers, each becoming the canvas for billions of microscopic transistors. The crystal is sliced into ultra-thin wafers, each becoming the canvas for billions of microscopic transistors. Even a single dust particle can ruin a microchip, making these cleanrooms among the cleanest environments on Earth. Now the real magic begins. Using light and extreme precision, microscopic circuits are transferred onto the silicon wafer. A light-sensitive material called photoresist is evenly coated across the wafer, preparing it for one of the most precise manufacturing steps ever developed. Extreme ultraviolet light transfers billions of microscopic patterns that will eventually become the chip's electronic circuitry. The exposed photoresist is developed, revealing an incredibly detailed blueprint for the next manufacturing stage. Highly energized plasma removes microscopic layers of material, creating features measured in billionths of a meter. Carefully controlled ion implantation changes the electrical behavior of the silicon, allowing transistors to function exactly as designed. Ultra-thin layers of conductive and insulating materials are deposited one atom at a time to build the chip's complex architecture. Each layer is polished to near-perfect flatness, ensuring every microscopic feature remains precisely aligned. After repeating these processes many times, an astonishing network of microscopic circuits emerges, forming the heart of every modern microchip. Every wafer undergoes microscopic inspection, where advanced imaging systems search for defects too small for the human eye to detect. Each chip is electrically tested before leaving the wafer, ensuring it performs exactly as designed. The completed wafer is carefully cut into individual chips with micron-level accuracy. Each silicon die is enclosed inside a protective package that allows it to connect with electronic devices around the world. Microscopic electrical connections are created with astonishing precision, completing the bridge between the chip and the outside world. Before shipment, every approved chip must survive rigorous performance and reliability testing. Only chips that meet the highest quality standards are approved for customers across the globe. From a single grain of quartz to billions of microscopic transistors, the semiconductor microchip has become the invisible engine of the modern world.